begin with the following identity. A to the nth power to the mth power is equals to a to the n times m. In other words, if you have exponent and exponent outside, they end up getting multiplied. So for example, if you have a to the third power to the fourth power, what is that same as? A to the 12th power. Now, why does that work? You don't have to know why it does work, but if you know it, it's helpful, right? So let me try to explain why this is the same as that. If you have a to the third power to the fourth power, what does a to the third power mean? A times a times a, right? You get the fourth power. And then fourth power means this is now repeated 4 times, right? And now count how many times a has been multiplied. 12 times, right? So it's like if they are handing out bags of candy, every bag has 3 candies in it, right? And you kind of hoard 4 bags. Now how much do you have? 3 times 4, 12 candies, right? Yeah. And so it's like the usual multiplication that you learned about in your like 3rd grade or 4th grade, right? If you have 3 in every bag and in 4 bags, 3 times 4, 12. That's why this gets multiplied in general, right? So that's the reason. But now let's talk about its implications. So, for example, if you think about, say, example 1, 27 to 2/3 power. How would you compute that? Well, in order to answer questions like this, you have to remember some powers. So it's a good idea to memorize these things. So it's like 2 squared equals to 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32, 2 to the sixth is 64. Those are the powers of 2's, and you should really memorize until 2 to the 10th power. How about 3? 3 squared is 9. 3/3 is 27, because 3 times 3 times 3 will be 9 times 3, which is 27, right? So actually, this one is 3 to the third to 2/3 power, okay? And you have to memorize a few more, like 3 to the fourth power should be 81. 3 to the fifth power is 243. 3 to the sixth power is 729. And then you give also powers of 4, powers of 5. 5 squared is 25. 5 cubed, what's 5 cubed? 5 cubed is 20 times 5, 25 times 5, which is 125. And then 5 to the fourth is 625. How about powers of 6? Maybe I'll write over here. 6 squared is 36. 6 cubed is 216. 7 squared is 49. 7 to the third power is 343. Something like that. So these are some of the powers that you should memorize. Okay, so we'll refer back to these numbers as we solve some questions. Okay, now how does it help if you have 27 to 3 cubed? Well, it helps because we're now ready to use this rule. If you have an exponent inside and an exponent outside, you can multiply them, right? So that means this is going to be 3 to the 3 times 2/3. How do you multiply a number to a fraction? The number gets multiplied to only the top, right? So this is going to be 3 to the 3 times 2 is 6. 6 over 3. What's 6 divided by 3? 2. And that's going to be 9. Okay? So once you know this, try to do the second one. try, say, 16 to 3 over 2 power. See if you can figure this one out. So the key is to look at 16 and think about 16 as some power. But I have the numbers here, so you should look up. Yes. That's right. That's right. Yeah. Okay, what answer did you get? Anyone else? 64, right? Yep. You're going to rewrite 16. I have 16 here, 2 to the 4th power, right? So you write it as 2 to the 4th power, 3 over 2. And then you use this fact that they multiply. So you have 2 to the 4 times 3 over 2, which is 2 to the 12 over 2, which is 2 to the 6th power. 2 to the 6th power is 64. Now, yes?
I have a question. Can you do 4 squared?
You can also, here's a second solution, solution 2. You can also say 16 to the 3 over 2 power is 4 squared 3 over 2. That's actually easier, right? Yeah.
That's right.
Because then it's 2 times 3 over 2. In this case, you can even cancel the 2 and 2's. So you get 4 to the 3rd power. 4 times 4 is 16, times another 4, that's going to be 64. So that's another way to do it. Okay. Now, what about 8 to the 1/3 power? Let's think about this. What is 8 to the 1/3 power? It's going to be 2, right? So if you have 8 as 2 to the 3rd power, 3 and 1/3, they multiply to give you 1. So it'll be 2. And once you do this example, you will start seeing some similarities with another mathematical operation, which is the cube root. What is the cube root of 8? It's also 2, right? So they are the same. 8 to the 1/3 power and cube root of 8 is same. And if you think about it, it has to be same because this is identical to saying that 8 is 2 cubed, right? If you take some number and cube it and you get this other one, that means that cube root of that other one should be what you begin with, right? But if you have 8 to the 1/3 power and take the cube, what do you get? 3 and 1/3 are reciprocal, so if you multiply them, it's 1. So you get 8 to the 1st power, which is just 8, right? So because 2 to the 3rd power is 8, and 8 to the 1/3 power of the cube is also 8, the cube root of 8 must be this, which should equal to 2. Right? And this is true in general. See, a to the 1/3 power to the 3rd power is a, and because of this, we know that cube root of a should equal to a to the 1/3 power, because that's what's the definition of this number is something that satisfies this equation. See, anything that satisfies this equation is called this, right? But I know that 8 to the 1/3 power satisfies this equation, so they are the same. That's the idea. So we're going to take this in general and write a second formula, which is that if you have 1 over nth power, that's same as nth root of a. Now, if you take that viewpoint, you can have a solution for these two questions using the nth root idea. So, for example, here's a solution 2. Solution 2 of 27 to 2/3 power is to think about 27 to 2/3 power as 27 to 1/3 power squared. Right? If you multiply 1/3 times 2, you do get 2/3 because any number multiplied to a fraction that only gets multiplied to the top, right? So 2 times 1/3 is 2/3. So they are the same. But we just said that 1/3 power is same as what? Cube root. So you're looking for the cube root of 27. You're squaring that one. What's the cube root of 27? 3, yes. 3, yeah. 3 times 3 times 3 is 27. So cube root of 27 is 3, and you get 3 squared, which is equal to 9. That's another way to think about the same question. How about this one? We can yet, for this question also, we can yet find another solution, which is solution 3. We already have one solution, two solutions. Solution 3 would be to say 16 3/2 power is same as 16 to the 1/2 power to the 3rd power, right? But what is 1/2 power in terms of radicals? 2 root of 16, but we don't write 2, it's just the regular square root. Did you know that? Square root means really this 2 is omitted, okay? Square root of 16 to the 3rd power. What is the square root of 16? 4 squared is 16, so 4 is what you get. If 4 to the 3rd power, again, that's equal to 64. All right, so that's just another way of thinking about the same thing. Sometimes people prefer this one, sometimes people prefer that one. You should know how to do them both ways. You sometimes need one over the other. Okay, example 1. Suppose you have x to the 3/2 power equals to 8. How would you solve that? Okay, we are going to use the idea of reciprocal powers. When multiplication happens, you end up with 1. So the solution is to take both sides and take the power of 2/3. Just like that. Okay. Reciprocal of 3/2 is 2/3, right? If you take 3/2, flip it upside down, you get 2/3. And what is 3/2 times 2/3? 1. If you multiply any fraction with its reciprocal, then they cancel and you always get 1, right? So this side, these two cancel and you get x to the 1st power. So you just get x. You get that? Yeah. Now on the right side, what is 8 to 2/3 power? Well, there are two ways to do it. One is to say that 1/3 power is same as cube root of 8. So you get cube root of 8 to the squared. That's one way to do it. Another way is just rewrite 8 as 2 to what power? 3rd power. Then this is 2 to the 3 times 2/3 power. Okay. And if you have same number upstairs and downstairs, you can cancel. So it's 2 squared, which is 4. Okay. So the answer is x equals to 4. Okay, if you're okay with this one, try to solve this next one. Y plus 1 to the 2/3 power equals to 81. So it's going to be y plus 1, 2/3 power to the power of 3 over 2, 81 to 3 over 2, so that when these two get multiplied, they cancel, you get 1. So you just get y plus 1 on the left side. On the other hand, you can rewrite 81 as 9 squared, right? So that when these two get multiplied, what do you get? 9 to the 3rd power. 9 times 9 is 81. 81 times 9 is 729. And then you can subtract 1 off of both sides. So 728 will be the answer. Okay, now let's do a challenging example. P minus 2 to the 2/3 power minus 5 times p minus 2 to the 1/3 power plus 4 equals to 0. This is very different from anything that we've done because before we could just simply take some power of it and then that gets rid of the fractional powers and you just had to figure out what the other number was. Here it's a bit different. You have a 2/3 and 1/3, so you don't have that kind of luxury to just take some power. So this requires a completely different approach. And the way we are going to do it is first rewrite this p minus 2 to the 2/3 power as p minus 2 to the 1/3 power to the squared. Right? Then 2 times 1/3 is 2/3. Is that okay? And now you rewrite minus 5 times, again, think of it as p minus 2 to the 1/3 power plus 4 equals to 0. Once you write it this way, then you see that p minus 2 to the 1/3 power is appearing twice. Okay. Is there a way to make use of that? Well, there is, and it's a completely different idea. The idea is called substitution. Just see whatever that is repeated a lot and just define it as something else. So just say it's equal to x. X is p minus 2 to the 1/3 power. See, I see p minus 1 to the 1/3 power here. I see p minus 2 to the 1/3 power here. Let's just call it x. See what happens. As long as we're sure that we remember this, I can call this anything, right? I can call this y. The equation still can be written in any way, right? So if I do that, then suddenly the equation becomes a lot easier. So what would this become? X squared. And then minus 5x plus 4 equals to 0. Oh, that's something I can solve. How do you solve this? You can use quadratic formula, but it's easier to factor. What are two numbers that multiply to 4 and add to negative 5? Negative 1 and negative 4, right? So you can factor this as x minus 1 times x minus 4 equal to 0. And then you can say, well, two things multiply to 0, therefore either x minus 1 is 0, in which case x would be 1, or x minus 4 is 0, in which case x must be 4. Okay. Did we solve the question? No, not yet. It's like, if you thought that was too easy, then you're right. That the story doesn't end there. And the reason is, if you try to say, check whether your answer is correct, and you try to bring 1 into here, you don't see any x, right? So you realize, oh, I need to, the question is asking me for the value of p. Did I get the value of p? No, I didn't. I kind of tricked. I just made something that contains p as new x, and I found the value of x. But that's not what p is. X is this thing, therefore, this result that we wrote actually means that p minus 2 to the 1/3 power equals to 1. And also, p minus 2 to the 1/3 power equals to 4. That's what these mean, okay? And therefore, you still have to solve for p. How do you solve for p? Same idea as before. This time, you just have to take the reciprocal of 1/3, which is 3 over 1, or just 3. 3 over 1 is just 3, right? So that p minus 2 is equal to 1 to the 3rd power. What's 1 to the 3rd power? 1. So p is 3. Done. How about here? P minus 2 to the 1/3 power to the 3rd power. You take the 3rd power both sides. What's 4 to the 3rd power? We did a few questions ago, right? 4 to the 3rd power is 64. Okay? 4 times 4 is 16. 16 times 4 is 64. And then you add 2, you get 66. And therefore, these are the answers. Okay? So that's the power of substitution. Substitution can make big, complicated-looking questions somewhat deceptively easy. And it is a bit of a deception because you feel like you've solved it, but you really didn't. You still have to go back and see what it means. Any questions? Yeah?
I need the 2 for the P minus 2 power 1/3 over by substitution.
What?
On the substitution right there, I need the 2 for the.
Which 2? This 2?
Up there.
Oh, this 2. Okay, we know that if you have exponents like that, they multiply, right? Yeah. So if you don't know how to go from here, always check if the inverse direction makes sense. Going this way, okay? So you have an exponent outside, and you have an exponent inside. Okay? And what does it say? They multiply, right? So what is 1/3 times 2? 2 over 3, because it only gets multiplied to the top, right? So you get 2 over 3. And indeed, this time this gives you this 2/3, so these are the same. So it's not so easy to go this way, but looking at this way, it makes sense. Any other questions?